Alright, so the paper you need now is this one that I gave you at the end of class yesterday, adding vectors. Okay, so it has all the notes on it, but I'd like to explain it to you. So you can either listen to me while following the paper, listen to me and then read the paper, but what I'm doing is on this sheet, okay? So yesterday I had said when we talk about vectors, we have to worry about direction. And because we have to worry about direction, we can't just add vectors the same way we add numbers. For example, if I had a box in the hallway and I want two of you to push the box, and so you're going to need to apply a force to it. And I'm not sure if you know, but forces are measured in newtons. So I could say to the two of you, if you each push with a force of like 200 newtons, you'll be able to move this box easily. And then I walk away. When I come back, the box is still where it was, because one of you is pushing with a force of 200 newtons this way, and the other one of you is pushing with a force of 200 newtons opposite. Now, this should, I hope, be pretty much common sense, because my money is on, as you're watching this, you're thinking, oh, well, because what's the total force or the net force here? Hopefully you see that it's 0. Well, what that's telling us is you don't just add vectors together the way you would add 200 and 200. You have to take into account their directions. In an earlier video, I had said to you, we usually call east positive and west negative. And so when you would add these together, it would be 200 plus a negative 200, and it would give you 0. Okay, so what we're going to look at in this video is how do we add vectors. And really the first 3 cases are like borderline common sense, or I'm hoping they are. But just a couple little notes before we get there. Whenever we add 2 vectors together, what we get as a result of adding those 2 vectors is called the resultant. It's a pretty good word. It's the result of adding 2 vectors together. And we can do it in 2 different ways. We can find the resultant graphically. So we could actually draw, like if I wanted to say, okay, someone's going 8 meters east, and then they're going, I don't know, another 4 meters east. I could actually take out my ruler, and I could measure, well, maybe I would do it to scale, and I would do 8 centimeters and 4 centimeters, and I could actually draw it to scale, and then I could measure the resultant. So we could find the resultant graphically. The other way we can find it is mathematically. So today we're going to look at the mathematical cases, but by the end of the week we'll start the graphing ones. Okay? Now, just as a note, see what I did here? This is the head, the arrowhead of an arrow, which represents the vector. This is the head of the vector, and the opposite end is called the tail. So this is the head, and this piece is the tail. Whenever you add 2 vectors together, you have to put them head to tail, okay? And then the resultant will always start where the first one started and end where the last one ends, okay? So they always have to be head to tail, and then you draw the resultant from where the first one started to where the last one ends, okay? So it's called the head to tail method. So as we go through the 4 different ways you can end up adding vectors together, the 4 different cases, you will notice that I will always be placing them head to tail to draw the resultant in. Okay, so there are 4 different cases in adding vectors together. Case 1, and these are the ones that I said are borderline common sense. Case 1 is if they're going in the same direction. Okay, so maybe if I use forces in that box, so if we had 2 people and one person is putting a force of 300 newtons on the box, east, and the other person is putting a force of 400 newtons on the box, also east, you all should be able to tell me what the resultant force that the box is experiencing is. Hopefully you're saying 700 newtons. Now, we have to add them together head to tail, so it would be like the 300 here and the 400 here. Right? And so then your resultant, my green wasn't very dark, so I'm going to try purple, except it looks like blue. Okay, the resultant would be here, starts where the first one starts, ends where the last one ends. It would be 700 newtons. It would still be east. The rule then, when you're adding two vectors that are acting in the same direction, the rule is add them and keep the direction. Remember I said borderline common sense? Hope that is. If two vectors are going in the same direction, we say the angle between them is 0 degrees because they're running along the same line here. Okay, so that's case 1. Case 2 is equally common sense. Case 2 is when they act in opposite directions. Okay, so this goes back to our two people with the box that were pushing opposite each other. So this time we have a 400 Newton force still going east, but our 300 Newton force this time is going west. Right? If we were to line them up head to tail, and yes, I do know you all have the answer already. If you line them up head to tail, there's my 400 newtons east, and yeah, I know I forgot to put east on up here. And then 300 newtons head to tail going back west. And the resultant is still starts where the first one started, ends where the last one ended. So it'll be right here. So it's 100 newtons, and in what direction? 400 east, 300 west. It should be 100 newtons east. The rule then is subtract them and keep the direction of the larger. Okay, the angle between these would be 180 degrees. So that's case 2. Again, common sense. Case 3, just as much common sense. Case 3 is, here's my box. Here's my 400 newtons going east. And this time, my 300 newtons is going north. So this time, they're acting at right angles to each other. And of course, right angles is 90 degrees. Okay, so we want to find the resultant, but before we can find the resultant, we have to line them up head to tail. So it's like one guy is pushing this way, 400 newtons east, and the other one is pushing this way, 300 newtons north. So this could also be you walking, right? You could go 400 meters east and then 400 meters north. Where is your resultant? I'm going back to green just because purple's too much like green, like the blue. It's a little bit better. Right? And so my resultant would be here. Starts where the first one starts, ends where the last one ends. How would you find it? Well, hopefully you recognize this as a right angle triangle, and so you would do Pythagorean theorem. 300 squared, 400 squared. It would give you 500 newtons. But we also need a direction. So you would need to find this angle, and you would find this angle by doing tan theta. Tan theta would be equal to 300 newtons over 400 newtons. Inverse tan of 0.75. It's 36.87. And so our final answer here would be 500 newtons, and then you would do a square bracket, and this angle is off the east, so you would write east first. And then you would put in your 36.87 degrees, and then you turned north, so you would put north here. and that would be your final answer. There's a fourth case